Okay, hey physicist, what's the crack today? So what we're doing is we're going to do velocity time graphs for someone that throws the ball upwards. Okay, so again, first thing I do is just draw my axes. So what I'm doing is a velocity time graph. So I'm going to have velocity on my y-axis, which is in meters per second. And I'm going to have time on my x-axis, which is in seconds. Okay. So I need to think through it. So it says a ball's thrown upwards. So I'm going to imagine a person, and what they do is they throw the ball up. Okay. So if I was to throw a ball up, I'm giving it initial speed. So it is going to have some speed in the upwards direction. Okay, because as soon as I let go of the ball, it's got a high speed in the upwards direction. And again, my upwards is positive. Okay, so it's going to have a high positive number. So at time 0, the initial velocity is going to be a high positive number. Then I know what comes up must come back down. So as the ball goes up, it's going to go do a projectile motion, a parabola motion. Okay, so I know as it goes up, it's going to decrease in speed, decrease in speed, decrease in speed, until it reaches its maximum height when its speed is going to be 0. Okay? So again, I know the speed decreases until eventually the speed becomes 0. And then as the ball falls back down, the speed will increase, 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 increase. But again, it's going down, so it's going to have a negative numbers, okay, because it's fallen down. So the velocity is going to increase, but we go to the negative part of our graph, and it's going to increase in the negative direction. Okay, so what I know then is that a velocity time graph, the gradient of a velocity time graph is equal to the acceleration. So just another sense check. So the gradient of a velocity time graph is acceleration. And when I let go of the ball, the only forces acting on this ball is the downward force due to gravity, because we're ignoring air resistance. So I know that the acceleration is g. My line should always be negative 9.81, which makes sense if I look at my data. Because if I draw a straight line for these points, the gradient is a negative number because the slope is decreasing. And if I do the math to find the numbers, the gradient of that line should always be negative 9.81.